question we've got here, although it involves finding the point of intersection of two lines, is actually quite a complex problem. You are presented with a triangle, which is here, and two perpendicular bisectors, one of which you know the equation, the other you have to derive. And once you've derived the equation for the second line, then you can actually work out the point of intersection. So it's quite a complex one. I suggest when you're going through the video, you may want to stop or pause the video and just go back again and double check what I'm doing. It might help to actually write it out as well yourself, just to get a grip of exactly what is going on and the different concepts that are presented here. So to begin with, let's just look at the question. It tells us that we have a triangle PQR and they give you the coordinates of P and Q. We don't know the coordinates of the point here at the top. It says that L1 is the perpendicular bisector of PQ. So this line here cuts PQ at 90 degrees and it's exactly halfway on that line. So we can just mark that on there just to show what that means. It says that the equation L2 is the perpendicular bisector of PR. So L2 also cuts this line here in the middle and at 90 degrees. They give us the equation of that line, 3r plus x equals 25. Sorry, 3y plus x equals 25. And we want to find the point of intersection of L1 and L2, which is C, so that's here. Now, we know one of the equations, so that's fine. If we can work out the equation of line L1, then we can solve using simultaneous equations to actually find the point of intersection. But finding the equation of line L1 is a little bit tricky. So let's break this down. So first of all, you've got to understand that line L1 is perpendicular to line PQ. So if it's perpendicular, then it means it's at 90 degrees. It means if we can work out the point of intersection and we can work out the equation of PQ, we can then derive the equation of L1. So let's have a look at PQ. So for PQ, we could say that PQ can be represented as y equals mx plus c. It's an equation of a straight line. We can see it from the diagram. It's a straight line. And we have two sets of coordinates. We have 3, 4, and 9, negative 2. They're both on the line. So we can substitute those values into our equation, y equals mx plus c, and actually have a pair of simultaneous equations. So I'll put the first one in there. So for the coordinates 3, 4, so x is 3 and y is 4, we can form an equation, say 4 equals 3, m is our gradient, plus c, which is the intercept. And that's going to be called equation number 1. And then for the point 9, negative 2, I can say my y is negative 2 and my x is 9, so I have negative 2 equals 9m, again plus my c. Now I have two equations with two unknowns, m being the gradient, c being the intercept. They're simultaneous, so I can actually solve them. Now looking at this, if I take equation number 1 and I multiply it by 3, I will get 12 equals 9m plus 3c. I'm going to call this equation 3. And you can see now that my 9m in equation 3 is identical to the 9m in equation 2. So with that knowledge, I can say I can subtract either 2 from 3 or 3 from 2. What I'm going to do here, I'm going to say equation number 3 subtract equation number 2. And I have 12 subtract minus 2. So it's 12 subtract minus 2 equals 9m subtract 9m, it disappears. 3c subtract c is 2c. 12 subtract minus 2 is equal to 14. And that's 2c. Remember, taking away a negative is the same as adding. And then if 14 equals 2c, c must equal 7. So I have a value for c. Now I can sub this into any of the numbered equations. I'm going to sub into equation number 1. And I have 4 equals 3m plus 7. So this means that 3m will be equal to negative 3, and then clearly m is equal to negative 1. So my equation then for the line PQ will be y equals m is -1, so it's negative x, and then c is 7, so it's negative x plus 7. More commonly, that will be written as y equals 7 minus x. Just a little point of note, but you can leave it in this form here. So that's the equation of my line PQ. Now, I also need the middle of the line PQ, because that will give me this point here, which is on L. So the midpoint, I'm going to put it on, I'll put it down here. The midpoint of PQ is equal to, so what I do here, I form a huge set of brackets here, and I look at my two x values, so it's 3 and 9, I add them, that's the 3 up here and the 9 there, and I divide by 2. And then I take my y values, so my 4 and my -2, and I add those, so 4 plus -2, and I divide that by 2. So what I got there, I got 12 divided by 2, which is 6, and 4 plus -2, which is 2, 2 divided by 2 is 1, so the coordinates of 6, 1 would be the midpoint, so this point here is 6, 1. So all I've done there is I've added the two x coordinates divided by 2, so that gives me the halfway point between the x coordinates going this way, and then when I've done the same for the y coordinates, gives me the halfway point this way, which gives me the midpoint. So I have the gradient of PQ and I have the midpoint of PQ. Now I know that L1 and PQ are perpendicular to each other, so if that's the case, I know that the gradient of PQ is equal to -1 over the gradient of L1, because they're perpendicular. So my gradient in PQ is -1, so -1 is equal to -1 over the gradient of L1. So the gradient of L1 must equal 1. So what I have here now is the midpoint of PQ, which is also on line L1, so this one here, and I have the gradient of L1, so I can use those to actually create the equation of the line L1. So for equation L1, which is a straight line, so it's y equals mx plus c, I know that m equals 1, and I know it goes through the point 6, 1. So I have a value for x and I have a value for y. So 1 equals 1 multiplied by 6, that's my gradient, multiplied by my x value plus c. So 1 equals 6 plus c, so c clearly equals -5. So I now have the gradient and the intercept, so I can write the equation for L1, and that will be y equals, my gradient is 1, so it's 1x, my intercept is -5, and clearly let's just tidy that up and say y equals x minus 5. I'm going to call this equation 4, you'll see why in a second. So that's for L1, and I know L1 intercepts with L2. L2 is in the question, so it's 3y plus x equals 25, and I'm going to call that equation 5. I've given them these numbers because I've already used 1, 2 and 3 to notate equations. So now I have two simultaneous equations. If I solve these, I can find the point of intersection of those two lines. Now, rather than using elimination to solve these, which I could do, I'm actually just going to use substitution because I've already got y equals something, and it's something quite simple, x minus 5. So I am going to substitute equation 4 into equation 5. So wherever I see y, I'm going to write x minus 5. So in equation 2 now becomes 3 bracket x minus 5, because that's my value of y from equation number 4, plus x equals 25. So let's tidy this up. I've got 3 times x, that's 3x, minus 3 times 5, which is minus 15, plus x equals 25. So on the left hand side here I have 4x, on the right hand side then I will have, let's see, that's going to be 40. So x equals 10. Now I have a value for x. Let's substitute that into one of my equations. Let's put that back into equation number 4. So sub into 4. So I have y equals to 10 minus 5. So y equals 5. So the point of intersection is 10, 5. Now, if I just look at it, go back to my little diagram here, 10, 5, I'm saying C is 10, 5. Well, the x value means the distance are going this way, so it's a little bit further than Q, so that kind of looks right. And 5 is a little bit higher than 4 in the y direction. So even from my sketch, now my diagram is clearly not to scale, but it even looks that it's kind of right. What I suggest you do is go back through this video, look at all the different steps, and really try and understand exactly what you're doing or what is happening with each one of these. There's quite a lot of maths involved with this, so good luck with this one.